And so I'll be recording. See if it gets started here. All right, it's recording. All right, so today what we're going to talk about is we're going to talk about density, and we're going to talk about how density plays a part in lava lamps. Okay, now have you seen a lava lamp before?
Yeah.
You said your sister has one, right?
Yeah.
And I will tell you that when I was young, this is one thing I asked my mom for many times for Christmas is a lava lamp. And I never did get one. So I'm still envious of anybody who has one. So I've learned to create my own. All right. So here I have my little lava lamp. Go in here. Do you see my lava lamp? Okay. Now,
Yeah.
what do you think's causing these bubbles to rise up?
Like air or something?
Okay, so it could be air. Do you have any other ideas?
Isn't it like some kind of like medicine thingy that you put in it that makes bubbles go everywhere? I don't know what
Okay,
it's
so
called.
well, we are going to be using Alka-Seltzer, right? Which is a medicine. And actually that medicine, when we put it in the water, is going to create carbon dioxide gas, right? It's kind of like soda. It has that gas. That's what's going to help us. But in a real lava lamp, they don't use that Alka-Seltzer. They're using heat to make things work. And so I'm going to show you that after we talk about some of the other things that are in there. Now notice you have two liquids. You have the liquid that's making the bubble, right? And you have the liquid that the bubble's floating in. And that's going to be a bigger reason for why the lava lamp works is because of the fluids that we have in there. All right, so that's what we're going to talk about today. Is we're going to talk about the fluids, and we're going to talk about what we call density. Okay, so when we talk about density, what we're talking about is we're talking about how much volume something takes up. Okay, and so some people want to think about this as like weight. Something's heavier than something else. And when we talk about weight, we most of the time we talk about what we call mass. Okay, and that means like how tightly packed together are the molecules, and how much matter is in that. When we talk about density, it's very similar, and I know that people get these three words confused. They get weight, mass, and density. They seem like they're so similar to each other that people get them confused. Okay, so we're going to talk about density, and then I'm going to talk a little bit about mass and weight so that we understand the difference between the three. Okay, but when you get on your scale at home, right, you get your weight. Now, weight, most people say, well, that's how much mass is in my body. And I'll be like, well, yeah, it's a measurement of how much mass is in your body, but I'm actually not measuring your mass when you get on the scale. What we're actually measuring is how much gravity it takes to hold your body down to the ground. Okay? Now, there's something funny about weight because we say, well, if we have different amounts of gravity, then it wouldn't take as much, or sometimes it would take more to hold you down. So if you went to the moon, which has less gravity, you would not weigh the same. You would be a lot lighter. So let's say I weigh 150 pounds, and then I go up to the moon, and I now weigh 65 pounds. Did I lose mass from going from Earth to the moon? Did I lose a bunch of weight?
No.
No, my mass is still the same, but because the gravity is different, my weight records different. So weight is actually the measure of how much gravity it takes to hold my mass down on the ground. If I went to Jupiter, I would jump from 150 pounds to 300 pounds. Now, did I gain 150 pounds on my trip to Jupiter?
No.
I hope I didn't, but my mass would be recorded by the amount of gravity that takes Jupiter to hold me down. And so the different weight is really a measure of how much gravity it takes to hold you down. Okay? My mass, my mass of my body is still the same, but the weight is different. Okay? So when we think about density, what we're thinking about is we describe how much space an object or a substance takes up in relation to how much matter is in that. Okay, so if you think about cotton candy, okay, cotton candy is very, very light, isn't it? It doesn't have, it has a lot of air in it. And so even though it would take up the same amount of space as this sugar, its substance, it's the matter itself is not as much matter. So it doesn't have as much density. So if I put cotton candy in this container, it's only going to weigh 30 grams. If I put sugar in this container, it's going to weigh 2,000 grams because of its density. It packs in more in that space. So if you've ever picked up a bowling ball, it's very, very heavy. It has a lot of mass. Whereas a balloon, which could be the exact same size, is very light because its mass, how much particles makes up that space, is different. So density is similar to that. The cotton candy takes up a lot of space, but it doesn't have as much substance, whereas the density of sugar is much, much heavier. So liquids are measured in density. We can say that some liquids are denser than others, okay? So when we compare density, we're comparing the molecules and the different masses of molecules. So if we are able to jam a bunch of molecules into this box, it's going to have more density than this that we didn't jam a lot of molecules in. So you're going to see this has a high density because there's a lot of molecules in that same space. This has low density because it doesn't have as many molecules in that space. And so liquids we measure the same way with density. How many molecules was I able to jam into this amount of space? Okay? So that's how you get the idea of whether something sinks or floats. Okay? So if the density of an object is heavier, it's more dense than the water, it's going to sink to the bottom and lay on the bottom because it has more density. Okay, if the water is denser than the object, then that object is going to float. It's going to stay up because the water is going to keep it up. So if something is less dense, it's going to float. If it's more dense, it's going to sink. And that's kind of how the lava lamp works. Okay, it works a lot with the density of the liquids. Okay, so if we take a look at this, we're going to do a little experiment. Okay, so I'm going to turn this off for a minute. Okay, all right, so what I'm going to do is I just have a regular glass, okay? And I'm going to start off by pouring some water in my glass, okay?
Do I do it too?
You can do it if you want, but you don't have to. This one I'm just modeling for you, okay?
Okay.
You can do it later if you want. Okay, now I've got my water in there. Now I'm going to take some of my vegetable oil and I'm going to pour it in here. Okay?
Okay.
Now, what happened?
The oil's on the top.
Yeah, and what's on the bottom?
The water.
Right, because what does that mean about the water then? What does that mean about the water?
The water's heavier than the oil.
That's right, it is more dense. There's more molecules in my water jammed into that amount of space than in my oil. So that makes my oil float because it's less dense than my water. My water is more dense. Now, I could play around with this a little bit, and I'm going to see if I can get things to sink or float on the different levels. Okay? So I'm going to start off, and I have a marble. Now, do you think my marble is more dense than the oil? Heavier?
No.
Okay, so if you don't, then it's going to float, right?
Yeah.
Okay, so we think the marble is less dense than the oil, so it's going to float. All right, so let's try it. What happened?
It sunk.
Okay, so what does that tell us about the marble?
It's heavier.
Right, it's more dense. It's more dense than the oil, and it's more dense than the water.
Water.
So we know that of this whole thing, the marble is the most dense because it's on the bottom. Okay, let's try a cap. This is like a Gatorade cap. Okay, where do you think it's going to be? Do you think it's going to be less dense than the oil and less dense than the water, or do you think it's going, where do you think it's going to be at?
Probably on the top floating.
Okay, so you think it's going to be on top of the oil floating. Okay,
Yeah,
so let's put it.
which way you put it in though.
Huh?
Depends kind of which way you put it in though.
Okay, well, I'm going to put it in flat. Okay, so let's see. So were you right?
Yeah.
Yeah, it is less dense than the oil even. Okay, now I've got a ping pong ball. What do you think about it?
It's gonna float.
Okay, and so we know that these are less dense. Now, here's my challenge. Do you think I can get something that floats on the water, but not the oil? That's kind of in the middle of my cup. Do you think I can find something that is less dense than my water, but more dense than my oil?
No.
You don't think that's possible?
Well, yeah.
You do?
Yeah.
Okay. All right. Well, you know what I'm going to do? I'm going to take my cap right here, and I'm going to add some density to it. So I'm going to pour in some water in my cap here. So what do you think happened? Is my cap now heavier or lighter?
Heavier.
Heavier. Okay, so I'm going to put it in. What happened?
It's in the middle.
Right. So it is heavier, it is more dense than my oil, but less dense than my water. So I can actually make things suspend in a liquid if I know how much density I have. Okay, and so I know that water is more dense than oil, and so I can test around different things to see which one is dense. If I know it's more dense, it's going to sink all the way to the bottom. If it's less dense than everything, it's going to float on the top. If it is more dense than oil but less dense than water, it's going to be suspended right in the middle. And that's what we have happen right here. Okay? So sometimes people want to call that magic. There's no magic to it. It's just straight science. Okay?
Okay.
All right. So that's one of our little experiments. And you are welcome, you know, on your own time to try some different things out to find out if they are more or less dense than water or oil. Okay? Now, the other thing I do, and this is the one my husband likes, this is called a density column. Okay? Now, I'm going to tell you how I made this. All right? Down here on the bottom, do you see it's brown? I put honey. Okay, this is honey. So I put honey in a cup, and then up above it I put corn syrup. It's clear. Okay, so I know honey is denser than corn syrup because they didn't even mix. They just settled right out. Then in this next little layer right here, I don't know if you can see, there's a teeny bit of blue.
Yeah.
Okay, that is dish liquid. I put dish liquid in there, and it is less dense than the corn syrup. Then I put red water on top of it. So then I have my red water here, which is less dense than my dish liquid. And then on the top, I have my oil. And this is what we call a density column. Okay, so I can see which liquids have more or less density based on where they end up in my cup. Okay, and I just experimented with some different things until I got the densities so that I have heavier, lighter, 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 lighter. Okay, and that's how really lava lamps work. Okay, so let's go back in here and I'm going to show you. So we did our little experiment there. So I could show you there. You can see that I can make different things float in different layers. So this is water. Okay, and this right here is it's water mixed with a little oil, and then, or not really mixed, but and then I have just plain oil on the top. Okay.
Mm-hmm.
Now, so what do you think would happen if I shake up my glass? What happens, do you think, if I shake this up?
It'll probably all mix.
Okay, then what do you think will happen if I let it sit?
It'd probably go back to normal.
Okay, what do you mean by go back to normal?
Probably just sit there.
Okay, do you think it'll sit there all mixed up, or do you think it'll go back to the layers that we have now?
Back to its layers.
Why do you think that?
Because if it's the top one and then if you shake it, it's not heavier as the other ones.
Right, so will it, have you ever seen salad dressing, like Italian dressing, and every time you let it sit in the refrigerator and you get it back out, what do you have to do to get it to mix up again?
Shake it?
Yeah, because if it, as it sits, it's going, the density is going to make the heavier or more dense liquid go to the bottom and the lighters go to the top. And so when you see things that are separated like that, you know that some of the ingredients are heavier than the others. So it'll mix to begin with. And then if I leave it sit, it will go back into its what we call density layers. So it will go back into its density layers after a period of time. Okay? So that would be a nice thing for you to test out and see if it really works. If we shake it up. But I didn't put mine in a bottle, so I can't shake mine up because I have it in my cup. All right, so here's an example of a density column. And I told you here's some things you could use. Honey, syrup, or corn syrup. So if you have regular plain syrup, you can use that. Dish liquid, water, food coloring, vegetable oil. And then you can see that they'll all separate out. If I shake it up, it's going to mix up. And then as I leave it sit, you're going to see that it's going to separate right back out again into its layers.
Mm-hmm.
Okay, so are we ready to make a lava lamp?
Yeah.
Okay, so we're going to take our bottle. You got your water bottle?
Mm-hmm.
Now, you might want to have something covering your table so that you don't, if when you pour stuff, it's not going to make a big mess. Go ahead and take your cap off of it. Okay, the first thing I'm going to do is I'm going to take some vegetable oil and I'm going to go ahead and put it into my bottle. And I'm using a measuring cup to pour it in because that makes my life a little easier. So you go ahead and do that and you let me know when you're ready.
I'm going to get to my sink real quick and do it.
That's probably a very good idea.
Is this enough or do you want a little more?
If you could put on a little more, that would probably work.
Okay. Is that okay or is that a little too much?
That's great. That's perfect. Okay. So now we've got our bottles of oil. Okay, now I'm going to, we know that oil is the least dense of all of the liquids that we've dealt with today, right? So we know that we put it in the glass, the water was denser, so it fell to the bottom. Okay, so what I'm going to do is I'm going to take some food coloring and I'm just going to color some of my water so I can see the difference in color. And it doesn't make any difference what color you pick. So whatever color you want your bubbles to be, that's the color you need to pick.
Can we mix them or something?
It's your lava lamp, darling. You mix away.
Yeah.
What color do you want?
I want red and blue.
Red and blue.
Now remember, if you're trying to make purple, go with more red and less blue, because the blue is more is more visible to your eye, and so it'll, if I would use more red and less blue to make purple.
I'm not trying to make purple. I'm just trying to put different colors in there. Bubble.
What happened when you poured it down in there?
They all stink.
Yeah, why? Why did that happen?
Because they're heavier than oil.
That's exactly right. So did you mix it with your water? And you're going to see how I have my green bubbles in the bottom of mine?
I'm going to go ahead and pour the water.
Okay, go ahead. It should mix with your food coloring.
Okay.
All right. Yeah. Mark, I want you to know Sarah's dancing to my clock.
Well, that's that clock. It sounds good.
Okay, so now, do you have your water on the bottom?
Yeah.
Oil on the top. Okay, now you have your little bubbles in there, right? Okay,
Yeah,
so why is the oil and the water separated?
because the oil is or the water's heavier than the oil.
Okay, I'm going to want you to start using this word. Ready? The water is denser than the oil. Can you say that?
Denser.
Right. So we're going to start saying those words denser. So right now, it's just going to stay just like that, unless I can make something happen in this water. So what I want to do is I want to add something in here that's going to cause a reaction. So what do you think we're going to put in here that's going to cause a reaction?
Alka-Seltzer.
Right. Now here's the thing. Alka-Seltzer only reacts with water. It won't react with the oil. So when I put the Alka-Seltzer in, it's going to go through the oil, and it's not going to do anything until the Alka-Seltzer hits the water. When the Alka-Seltzer hits the water, it's going to start releasing the carbon dioxide gas. And that gas is going to pick up the water bubbles and send them up through the oil until the carbon dioxide busts at the top and then the water falls back down. So I want you to get out an Alka-Seltzer tablet. Okay. And then I want you to break it into a couple of little pieces. All right.
It's starting to work.
You already have, do you have it broken? Okay, now go ahead and put one in there. And then I want you to watch.
Pretty.
Do you see it pulling up the green bubbles in mine?
Yeah.
Is it doing that in yours? Is it pulling up?
Yeah.
Okay, because and I can stick in another one and make it go for a little longer. So that carbon dioxide gas is picking up that water with that coloring, bringing it up through the oil, and then when those bubbles pop at the top, it drops my bubbles of water back down to the bottom because they are denser. So every time I put an Alka-Seltzer tablet in here, I'm going to make a what? Yours is
Bubbles.
cool.
Mine turned black at the bottom.
Yeah, but I love that. Yours
What
is
is
way
happening
cooler
on
than
my
mine.
front? I put them all
That's
in
okay.
there.
Now, you have just made your own little lava lamp. The only thing is you don't have a light underneath it. That's the only difference. So right here, this lava lamp I bought for $9.99. I'm going to, because the only thing that's different between what you did and what I did is this one has a light at the bottom. That's it. That's the only difference. So if we wanted to, we could put a little flashlight underneath here, and I've got my own lava lamp. And I didn't pay $9.99 for it either. There you go. You have a lava lamp. So anytime you want your lava lamp, anytime you want to see your bubbles, what are you going to do?
Get the Alka-Seltzer. I don't know how to pronounce that.
Alka-Seltzer. And then you just add it into the water and you have your lava lamp working again.
Put them more in. There it goes.
Now, the only thing I'm going to tell you is don't fill it all the way to the top with water and put a cap on there, because if you do, you're going to have a big giant mess. So make sure you keep that lid off of your bottle, okay? So when you're not using it, when the Alka-Seltzer's gone, you can put a cap on it and put it to the side. And then when you want it to work again, you uncap it, put your Alka-Seltzer tablet in, and voila, you have your own lava lamp. And that's all just from water, food coloring, and oil. That is so cool.
There's bubbles everywhere.
I know, isn't it awesome? Science is so cool. So all of these things that people are selling as STEM toys for 20 bucks for Christmas, you can do it right here for free. Okay, so that's right. So, and that's all from density. So what we did is we had our density of the solutions, and we have a reaction with our Alka-Seltzer tablet creating the carbon dioxide gas. And that's all this whole thing is created from. Now, in lava lamps that work all the time, there's a little bit of a difference, okay? They're using heat to make the reaction, okay? So as this light, the lava lamps, when you get a lava lamp from somewhere, you have to turn it on and leave it on for a little bit before the bubbles will start, because the bubbles won't start until I have this light on and it gets enough warmth to heat up the liquid. Because when the liquid heats, the water begins to get lighter because it's turning into a gas, and it'll float up to the top. When it hits the top, it gets cooler, and then it'll fall back down to the bottom. So instead of using Alka-Seltzer, all I'm doing is heating up that water to create that same reaction that I get from Alka-Seltzer. So that's really the only difference between a lava lamp, that you would say a real lava lamp, and what we've created is that the reaction that we made, instead of using heat, we use the Alka-Seltzer tablet to do the same thing. Okay? So let's go back to our presentation, take a look at it, and see if there's anything I'm missing. Okay, so now can you do this again on your own without me?
Yeah.
Okay, could you explain it to somebody?
Yeah.
Okay, I want you to explain it to me, and then I will tell you that you can do it on your own. But if you can't explain it to me, I'm not going to let you do it on your own. All right, I'm ready.
Okay. So you grab a bottle and you take off the cap. And then you get your, and then you fill like a quarter of it, of the bottom of oil. And then you get water, and then or you get your food coloring and then your water, and then it mixes, and then you put the
Alka-Seltzer.
Alka-Seltzer, and then all of your bubbles start, but when it stops bubbling, you can put on the cap, but if the bubbles keep coming up, you can't put on the cap or it will explode.
Okay, now tell me, why does this work?
I think.
Come on.
What?
What's the big word?
Why does this work?
Density.
Right. What's more dense?
Lower.
Okay, so which of those liquids is more dense, water or oil?
Water.
How do you know that?
Because the water goes like down, and then the oil stays up.
Right, and that's how we know. So you need to have two liquids that are of different densities, okay? So that's where we got the oil and the water. Now, why did we use Alka-Seltzer? Why does the Alka-Seltzer produce those bubbles?
Because it has some kind of like fizzy thing in it.
Yeah. It creates a chemical reaction. Are you ready?
Yeah.
In the water, and when it reacts with the water, it creates a carbon dioxide gas. So you have a chemical reaction. Does it chemically react with the oil?
Yeah.
No, it doesn't. Only the water. If you put the Alka-Seltzer in the oil, it won't do anything. It has to reach the water before it'll make any reaction, and that's why it's picking the water up and not the oil. Okay? So the Alka-Seltzer won't react with the oil at all, only with the water. Okay? And that's what makes this reaction special. Okay, so here you can see that I've done different ones. I have red, I have blue, you have a black one, I made a green one this time, and we can tell that it's density. Okay, so what role does density play in the lava lamp? So we know that, how does density play a role? What do we know about it for this lava lamp?
I forget.
Tell me what you, look at your lava lamp and tell me, what do you know about density here?
There's more, the water has more density than the oil because it's lower, and then the oil's higher.
Here's something I found on the web. According to
The water is on the bottom. Is that what you said? Or you said it's lower. Lower in the bottle. And the oil is higher. Very good. So now you've learned that different liquids have different densities, and it's the density of that liquid that creates the illusion of the lava lamp. Okay, so the ingredients in Alka-Seltzer combine with water to form a gas called carbon dioxide. That's what you're getting here. The oil and the Alka-Seltzer do not combine in this way. So since the Alka-Seltzer tablet is more dense than the oil, it's going to sink right through the oil, hit the water. That's when the reaction begins and the carbon dioxide gas is formed. Okay, so when the Alka-Seltzer dissolves in the water, it creates that carbon dioxide gas. The gas is less dense than the water in the oil, so it bubbles up. It takes bits of the colored water with it as it moves through the oil layer. And then at the top, the bubbles burst, releasing the carbon dioxide, and then the colorful bubbles sink back down to the bottom because they're more dense. And that's how lava lamps work. So if they don't have the Alka-Seltzer, they're using heat from the light to create that same kind of reaction. Because the heat makes that the molecules expand, and then they go up to the top, and then when it gets cooler up there, they pop and come back down to the bottom. Same idea. Okay, so these are some extensions you can do later if you want. Find out if temperature of the ingredients change the behavior of the colorful blobs in your lava lamp. So Do maybe hot water with your oil, and then do cold, really cold water with your oil. See if it makes any difference. Okay, so if you want to do an experiment later without me, try really hot water with your food coloring, and then your oil, and then try with your Alka-Seltzer tablet, then try really, really cold water and see if it makes any difference. Or you can make your lava lamp. You can stick it in the refrigerator or freezer for a few minutes, pull it out, put the Alka-Seltzer tablet in, see if it makes any difference, if it's hot or if it's cold. You can do the same thing for hot. You can put it in a bowl of hot water, make it hot, put your Alka-Seltzer tablet in, see if it makes any difference with your bubbles or makes any different bubbles. Okay? So those are some science experiments you can do on your own. All right, so just remember when you're done, you clean everything up. And another thing I'm going to tell you is don't pour your, if you don't want this lamp, don't pour the oil down your drain if you have a sewer system, because it'll clog it all up, okay? So if you don't want it, you need to probably go outside, pour it in a compost pile, or dig a hole in your yard away from any plants, and then just pour it in there, okay? Do not pour it down your sink, okay? Now, I usually just put my cap on mine and then I use it later. So anytime I add Alka-Seltzer, yeah, I have my lava lamp again. Do you have any questions for me?
No, I think I'm good.
All right. Well, we will not be meeting again until after Christmas, okay? So our next science lab will be January the 5th, okay? So have a very, very Merry Christmas. I hope you enjoy your time at home with your family. And I hope to see you January the 5th. All right?
I've signed up again.
All right. You can put your little flashlight underneath there. I love it. It is so cool with the black. I love it.
It's purple, mostly. It looks like black, though.
Oh, that is so cool. You did an awesome job.
Yeah.